Welcome to the Stormsurf video surf forecast for the week starting Sunday, November 1st. Looking at significant wave heights for the North Pacific Ocean, we see not a whole lot going on. A gale off of British Columbia, Pacific Northwest, is generating 20-foot seas and has been since late yesterday. Swell from that system is already reaching into Northern California, been confirmed at the buoys up in the Point Arena area and working its way south. Will reach into Central California tomorrow morning, but much north wind is expected with it, with high pressure right out here. As soon as this low moves inshore, big gradient sets up, a lot of north winds for multiple days in a row. A little bit of a cutoff low here north of Hawaii, not doing a whole lot. And another system is up here in the Bering Sea, completely landlocked north of the Aleutian Islands. No swell to result from that. Let's get into the details. First up, let's talk about jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, helps direct their track. We're looking for a strong, consolidated jet with a big trough in it, and we don't see it. What we see is a split jet stream coming off of Asia, consolidating south of Kamchatka, but heading north, splitting yet again, doing nothing here, and then finally consolidating just off the U.S. West Coast. Here is a little bit of a trough that is a dip to the south in the jet. That helps support counterclockwise circulation aloft and down at the surface, and that is the hallmark of a low-pressure system. And sure enough, there is a low-pressure system there, we believe, and it is generating seas that are radiating south into California. Let's take a look at the future, and we have some thoughts on why things, we'll just sort of spoil it here and say things don't look great. Okay, again, the split here into Monday night. Tuesday, a little bit of a trough finally come Wednesday here over the North Dateline region. That should help support gale development. Decent winds, almost 130 knot winds starting to dive into it. And that rolls basically over the Aleutians into Thursday and then into the Northern Gulf into Friday and then makes its way into British Columbia by Sunday. And then finally we get a somewhat consolidated jet here, but displaced well to the north, up at almost 50 north, whereas all previous to this, it's been the jet has been down around 40 north. Consolidated, yes. Troughs, no. Not a whole lot going on. What is going on? The immediate reaction would be the inactive phase of the MJO, and one would go, well, hey, the jets, we're in El Nino, the MJO should be sound asleep. But the reality is we're thinking that there is some minor, in this case they would call it destructive interference with the El Nino pattern, and we can see that at multiple levels with the slackening of westerly anomalies and the split jet stream and the storm track kind of not doing what it should be doing. And in fact, the inactive phase of the MJO was just forecast to start about the past couple of days, and sure enough, it appears to be having some influence. We had completely written it off, and we'll get into that in a bit. But anyway, that's it in a nutshell. Let's go down, take a look at the surface. And here we go. Surface level pressure, surface level winds. We see a high pressure system, 1032 millibars here north of Hawaii, and as expected, cutoff low just south of it, creating a little fetch. Not good for anything, but it's there. We saw it on the wave model chart. And of course, here's our low pressure system we saw over British Columbia, generating fetch, 35 knot winds. That has generated actually up to 24-foot seas earlier, and that swell is, of course, radiating into Central California. And then here's our other low north of the Aleutians, not doing a whole lot. Let's put this into motion. We zoom through this high pressure. Now notice this, as the low moves inland, high pressure starts building 1036 millibars before, here we go, we just get it right to Monday morning, and look at the north wind circulating here, gradient between low pressure that was here, high pressure here, big fetch and north winds in the 20-25 knot range, no good. And actually, here's the front right here too. I mean, it's pretty plain and obvious, and that works its way south. And the wind machine kicks up. Now watch this. We even push it. It goes into Southern California. So the expectation is by late Monday, big north wind all along the U.S. West Coast. The sad part about that is it's going to wipe out some of our warm water depending on how long it blows. Not a whole lot going on over here because we saw the fragmented jet stream flow aloft earlier. Anyway, here we go into Wednesday, just more high pressure. And finally, remember that dip in the jet we saw? Here comes a little storm. What is that? 60 knot winds over a small area late Tuesday night into Wednesday. Over the north dateline region, the core low is right over the oceans, but all the fetch is south of there, aimed basically up the Great Circle Pass to the U.S. West Coast, and we'll take a look at that in more detail in a minute. But anyway, winds finally die along the U.S. West Coast. We can actually take a look back here, by about Wednesday or so. So it's 3 days of north winds. Anyway, and then the low works its way into the Gulf and finally starts petering out on Friday. More high pressure here north of the islands. More fetch in the Gulf of Alaska into Sunday, and then that pretty much is the end of that. So basically looking at this, there's one solid system on the charts tracking from the north dateline region into the Gulf of Alaska starting midweek. Let's go down to the surface and see the effects of those winds on the ocean. And here we go, significant wave heights for the North Pacific Ocean. Again, our low off of British Columbia, 20-foot seas. Let's go back and take a look in the past and see how that one evolved. And here we go. It started on Saturday, 18-foot seas, 19-foot seas. Finally got semi-organized on Saturday night. That is 22-foot seas on the Great Circle Path, but very north relative to Northern California, somewhere between about 308, maybe, let's say 38 to 310 degrees. Swell is already starting to move its way into Northern California relative to Southern California. For the most part, just barely, what is that? That's about 312, I believe, 311 degrees, right on about as far north as you can possibly get into Southern California. That will reduce size significantly and rideable only at the most exposed breaks. Anyway, from there, it pretty much moved inland out of the paths for either Northern California or Southern California. Now we're into the forecast. Let's go back to the other chart. Here we go. All right, and rolling out. We roll this through. We just see not a whole lot going on till we get here, till Wednesday, and we get about, 39-foot seas, pretty far to the north, and we can roll this one here too. We'll do a dueling. There we go, 12Z. Dueling wave models relative to Northern California, 301 degree track, relative to Southern California, about the 305, relative to Hawaii, about the 330, 328 it looks like or so, but notice most of the energy is going this way, cutting across the Great Circle past to Hawaii. So it's sideband swell only for the islands. Anyway, we'll put this into motion. It continues, builds, peaks out, looks like about Wednesday night. What is that? 43-foot seas. Again, all aimed mainly at the U.S. West Coast. And then it continues into the Gulf of Alaska into Friday and then fades out. For the most part, this is a swell for British Columbia, Pacific Northwest, down into Central California, with bits of energy into Southern California, sideband energy for Hawaii. And you can actually see it on this model here. Roll that out. It kind of doesn't do so well in terms of hitting Hawaii, but you can watch it working its way towards the U.S. West Coast for later in the weekend, assuming it forms. And then after that, not a whole lot going on, a little bit maybe hint of something here, and maybe another something up here in the Gulf of Alaska, but who knows whether, 180 hours out, these models are not believable. Also, we had a question where the models with the great circles on how you can get to that. So here you click models, and that's where we are here, models, boom, wave models, and if you scroll down right here, this is the high res tool. The full screen version of it's just a giant wave model, but the full screen version is here, and specifically if you're interested in the southern hemisphere, it loads here, and then you can get your great circle paths into California, Northern California, Southern California, or wherever. So there's that little bit of secret inside information on how to get some of these tools. And since we're here, let's take a look at the southern hemi, since we're done pretty much with the northern hemisphere. And there's one little thing that we want to look at here. This is starting later Friday. A gale developed southeast of New Zealand and into Saturday. Look at that. It got up to 30-foot seas on the Great Circle Path. What is that? 211, 210. Let's roll that back one more. 211 to Northern California. That's barely unshadowed by Tahiti. Relative to Southern California, that is the 213, but that is shadowed by Tahiti. And then relative to Hawaii on the about 190 degree track, And actually pretty decent, 30 degrees either side of the main swell vector coming out of these storms. You get no loss of size. So that's pretty decently on the track to Hawaii as well. Anyway, roll this out. That system is already gone. Another little one down here further south is forecast on Monday. 32-foot seas, and you go, oh, maybe there'd be bigger swell. But the reality is, relative to Northern California, yeah, it's aimed up there, but it's that push right up the Great Circle paths that makes a giant difference in how much swell ultimately arrives at any particular target. And this one's more cutting across the tracks, especially regarding Hawaii. So not as much size expected for that. And then after that, a much quieter pattern is forecast. We'll just roll it out here. And that's pretty much the end of it. And irregardless, with the system in the North Pacific, that swell will pretty much swamp anything that's generated by the Southern Hemisphere. But, you know, maybe next weekend, Southern California, since it's pretty much going to be a lot shadowed from that system that's forecast up north, it might do okay from the Southern Hemi swell, especially those that are really protected from the north. So that's that. Let's get down to business. El Nino 2515. Good things are going on. Major improvement. We'll hold off, show you in a moment, but let's get into the details. So here we go where we typically start at. This is the top chart is actual winds, actual water temperatures. Nice warm pocket of temperatures here, just east of the date line. Notice there is not as warm a temperature here. All the warm water that was over here is working its way off to the east now, driven by consistent, non-stop either westerly anomalies or westerly winds for the better part of a year now. There's been no easterly anomalies whatsoever. You can't ask for much more from an El Nino than that. We're looking for any signs of westerly winds and just a little bit of hint here, but that's about it. In the anomaly regard, yes, we still have westerly anomalies, and we'll talk about that in more detail in a second here. And as long as you have westerly anomalies, consider that normally you have trades blowing the whole way across here, blowing from east to west, very hard. Notice trades are gone. It's basically dead air. That's the equivalent from a water movement standpoint of a current that pushes things to the east. So they call it westerly anomalies and depict it as such. And clearly that's in place. Let's go dive into the models real quick. So here we are. We call this the Kelvin wave generation area. Conservative, 3 degrees north and south of the equator. New Guinea here, basically between about 135 east, and actually it goes a little bit east of the date line. We'll go through this real quick because there's not a lot to see. Notice in the main part of the area here, basically no wind. If we saw west winds here, that would be great, but just no winds is a great thing. East winds would be the norm. East winds in the 10 to 15 knot range. A little bit of east winds way up here in the north portion, maybe a little pocket right there, but basically not a whole lot going on. We'll just roll this out. You see, yeah, these east winds up here in the north portion just kind of, they're there, but they fade out. And basically looking here in the core, nothing is forecast. If anything, it gets deader, and deader air is the equivalent of westerly anomalies. That enables warm water here to move off to the east. And then here's part 2 of that model. This is from the date line eastward, and only it goes to about here. Once you get westerly winds east of this area, you can't really get a Kelvin wave, and that's what we're trying to see. Westerly anomalies push warm water to the east, but what happens is that warm water somewhere in this region starts falling to depth, and it literally travels under the equator, down about 200 meters, the whole way to the Galapagos Islands. So this is the area we're looking for west winds. We'll just roll this again. We don't see any west winds, but we don't see any east winds either. If anything, we just see a dead, oh, look at that, actually a little bit of west winds 78 hours out, but they're not long lasting. It's just kind of a transient flow. And not with any velocity, certainly not westerly wind burst material. You'd want to see at least 10 or 15 knot west winds. So basically, calm pattern the whole way through. That's the equivalent of westerly anomalies, but it's not nearly as strong as what has been going on in spurts for the better part of 4 or 5 months. And here's another way to view it. This is back in time, going towards the future down this scale. This is the whole planet, but the Kelvin wave generation area, the area bounded by the previous 2 models we just looked at, runs basically, down a line down here through about here, okay? And these whites are actual hard westerly winds. This is a major westerly wind burst that occurred pretty much the whole month of October, kind of faded for a second, then got going again the whole way through October. Now, these are more anomalies than westerly winds. This westerly wind burst, both these blobs together, has created, this is westerly wind burst number 4 for the year, and we believe has created a 4th Kelvin wave, and equivalent in strength to the 3rd Kelvin wave, and we'll talk about the 3rd Kelvin wave in detail in a moment here. We're just sort of getting you through the forecast. Little bit of, notice this east winds here, and here's the scale down here. This is often the far western Pacific, and this is when we start talking about thoughts about the inactive phase of the MJO. Right here you see weak easterly winds almost making it to the dateline. Maybe not. Westerly winds persisting, but notice they're sort of moving off here, to getting displaced a little bit to the east. Probably not supportive of Kelvin wave development. The cutoff line is right along here. So, but that's not horrible. I mean, not a bad situation. Let's go take a look at the long-term forecast. Now, this model's a little bit different. The past is down here. The future is up at the top. Oranges and yellows are westerly anomalies. There's the date line running right down the middle of the picture here. Kelvin wave generation areas goes from about here to, somewhere over in this range. So here you go. We see, here's this big westerly wind burst that happened in the June-July timeframe. This is what generated, this is westerly wind burst number 3. It created Kelvin wave number 3, which is erupting in the eastern Pacific over the Galapagos right now. Here is the most recent westerly wind burst that occurred in October. That was what we just saw on the previous chart. Pretty much the whole month of October was either strong westerly anomalies or westerly winds. And now look at this. Here we are, and boom, things really settle down right in here. Not as strong westerly anomalies. Why is that? Well, we have some thoughts on that. But notice also when you get into December, westerly anomalies are supposed to pick up. And typically in a strong El Nino, this is exactly, we would expect this to be continuous the whole way through here. So here, let's just get to it. MJO. Notice the strong westerly anomalies both here and here. The MJO is the dark red isobars or contours, if you will, and strong westerly winds there and there, both associated. And we were kind of writing this off, saying that's not really the MJO. MJO doesn't happen, especially during what is nearly a super El Nino. But notice this. This is the inactive phase of the MJO, and there's many signals, both at the jet stream, the lack of westerly winds, and we saw it on the previous model. They're supposed to die out. The thought is there is a weak inactive phase of the MJO in effect right now. And you know what? That's not the end of the world, but it will make the jet stream suffer a little bit. It will cut down storm productivity from now until about maybe somewhere in the first week of December. So November's kind of a write-off is what that suggests. I mean, there'll still be surf, just not solid-size surf. But then come early December, if this model is right, and if anyone wants to believe a model, this is the CFS long-term model. It's actually been doing okay. So if you were to believe it, things are going to go nuts in December, according to this. And then we add yet one more past this, the equatorial Rossby waves. Now notice, equatorial Rossby waves, when they interact with the MJO like they did, with the MJO and El Nino base state like they did here, and here you get stronger winds. And even with Rossby waves in here, not a whole lot forecast to happen. But then you get into December and things start going again, kind of nuts. And then here is your El Nino base state. Some models had been suggesting El Nino was peaking out right about here, right about now. Sure enough. But then this model also suggests that it's going to hold and solid, starting to ease to the east some, these westerly anomalies. So they might start moving out of the Kelvin wave generation area, but maybe not completely. I mean, the dateline runs right up the middle through here, and you still have strong westerly anomalies right on the dateline. So if this happens, the interesting part is you get these westerly winds, you get a Kelvin wave. It takes 2.5 months for the Kelvin wave to make it across the Pacific. So you're into, let's say the Kelvin wave gets going January 1st. So you got January and February into middle of March before the resulting Kelvin wave even erupts over the Galapagos, and another month before it advects back into the Nino 3.4 region. What this hints at is that we could have a very long-lasting El Nino episode. Again, am I going to believe a model that's a month or more into the future? Absolutely not, but it's a nice tease, something to look forward to, and the model has consistently been suggesting this pattern. You know, the details are fuzzy. The start of the active phase, inactive phase warbles around by a week or two, but it's been on here for a month or two now, and we've been talking about it. Still in play, so who knows? We'll see. And speaking of the MJO, real quick, we'll go through this. This is the statistic model forecast. We've basically been writing this off for the past couple of months, too, because the pattern has been this inactive phase that's just locked over here, and then nothing in the Kelvin wave generation area right here near the date line on the equator. And what we see now is, at least per the statistic model, inactive phase. It's peaking out right now, which would suggest that maybe the biggest damper on storm development is occurring right now, and maybe by, 5-8 days out, things will start looking better. And it actually suggests, this model, that the active phase of the MJO moves in earlier. But the dynamic model is more consistent with the CFS model, that long-range model we just saw, basically saying things just sort of fall back into the pattern where they were. And if that's okay, that's not bad too. Maybe storm development would pick up, because you got to remember, El Nino is the main controlling interest in this area, in the Kelvin wave generation area. Yeah, maybe it's getting stepped on a little bit here for the next week or so, but beyond that, maybe things will pick up. Hard to say. And we've seen these before. These are kind of tough to, these are MJO forecasts, two different models. The forecast, here's the line. This is for the active phase of the MJO. It's suggesting the active phase currently, right now, is in the Indian Ocean, working its way towards the maritime continent, Western Pacific. Our interest, we'd want to see this line go out in here. We don't see that on either of these models, either the GEFS or the ECMF. Basically, both these models suggest the active phase of the MJO is to die in the Indian Ocean, but we'll see. It's hard to say. All right, on to more interesting things. So we talked about westerly winds, beat that to death. We talked about the MJO, and the supposed inactive phase of the MJO, weak as it may be, is occurring. And now the effect of non-stop westerly anomalies for the better part of, we'll say a year or more, but certainly in the past 6 months. Over in this region, the Kelvin wave generation area, we're looking down at depth. This is the West Pacific. This is the East Pacific. These are buoys strung across the equator. And the anchor line sensors on those anchor lines to try to understand the subsurface water profile. Currently, we see a large tongue of warm 29 degrees centigrade water at depth, not super far down, but certainly pushing off to the east. You can see it just in the pattern. And the major 28-degree isotherm locked at about, 125. And we've been monitoring this line here and this line here in the written report we publish a couple of times a week. And this guy keeps inching off to the east. This guy is locked solid. And notice not so much warm water over in here. This is where we're when we talk about the warming, this El Nino being a little bit westward displaced compared to 97, this is why. In 97, these guys were about this time of year moving. There is much more warm water moving into this region. Now, this is not a bad thing. It just says that most of the warm water will be actually due south of Southern California. That's kind of the line right there. Anyway, this is actual water temperatures, but it's the anomalies, differences from normal for this time of year. This is really, there's a classic sign, Kelvin wave here, and it's much more than a Kelvin wave. This guy has just been locked here. Actually, about a week ago, he died back significantly. He was down to like 5-degree anomalies here. All of a sudden, he ballooned up again, and notice these anomalies go the whole way. Where's the date line? Right there. So right there, here we go, right there. So these anomalies start, if you have west winds here, you literally can see the warm water falling to depth. And then this is basically not a distinct Kelvin wave. It is a reservoir. There has been multiple Kelvin waves, pockets of warm water that have moved here, and now they're just permanently setting up shop. It's just like a spigot of warm water just flowing down. So Kelvin wave number 3 was here. It started to fade out. Then there was this big, another bit of westerly winds that occurred here in October we talked about. They're all starting to bulge out, move into the reservoir here, just feeding this guy yet again. The expectation is it'll be mid-October, this westerly wind burst start. We won't even see the Kelvin wave erupt from this guy until probably right around Christmas time. This guy will start working his way to the surface. And then the whole question is, well, is there going to be another westerly wind burst? We saw in the previous chart in the December time frame, yet maybe more westerly winds, maybe a bit of a fantasy. And even by the time it erupts, it's probably almost too late in the year to do a whole lot, but either way, very impressive situation. Etch this in your mind. You do not see these situations, but maybe once every 15 or 20 years. And again, something to remember. Another version of that chart, a little bit higher fidelity. Westerly anomalies would be out here. Here's the date line. Warm water falling to depth. You can just about see it. Hints of the new Kelvin wave number 4 developing here. Much warm water here. There was actually this area. This is 4-degree anomalies. There were fingers of it popping up here in about a month ago, and you could actually see the eruption of those fingers on the ocean surface, and we'll get into that in a minute. Those have all disappeared, but notice here, this is 3 degrees anomaly, and it's a solid wall from 140 west to about 100 or so, almost to the Galapagos. So one would expect to see significant warming at the surface from this. This is basically sideband energy, the core part of the Kelvin wave, or this big reservoir down here. Very impressive indeed. And yet another view, we've seen this before, sea level anomalies. West Pacific here, East Pacific here. Here's the U.S., Mexico, South America. You take, this is all from the Jason-2 satellite, strip out all the waves, strip out the tides, strip out the chop, strip out any, gravity effects, anything. And this is actual differences, just like a bulge in the ocean right here, all attributable to very warm water, subsurface on the equator here. Warm water expands, and basically pushes water above it up, creates a little bulge. We're talking 15, 20 centimeters, not much, but the satellite's accurate to about 1.5 centimeters. So a pretty good way of giving you a hint of where warm water is. The other part, this was baselined on October 25th. It had one little pocket here, but we've noticed this on all these charts. They say that they're as of this date, but almost daily there's very subtle little fluctuations that occur in some of the fine measurements if you keep your eyes on them. And this is one of those. It was only one pocket of 20 centimeters. Now it's a double lobe actually building. That is consistent with what we're seeing on the subsurface charts, that this Kelvin wave number 4 is building and growing in size. The reservoir is growing. Again, just more evidence suggests there's a lot of warm water at depth. And yet one more chart. We've seen this before. West Pacific here, East Pacific here. Time going back last year. Little Kelvin wave. Upwelling phase of the Kelvin wave cycle. Cooler water off Galapagos here. Then boom. A pretty solid Kelvin wave that occurred in the March-April time frame. Another one in the June time frame. Massive Kelvin wave. This is from the June-July westerly wind burst. Occurred right here. These are 2.5 degree anomalies. And now Kelvin wave number 4 here. And notice it's the interesting part about this, we'll just sort of look at this. It's starting in the same place. It's getting these kind of numbers, 2.5 degree anomalies. This is over down to a depth of 300 meters. And it's now, when we first saw this chart, this was, again, the day. Where's the date on this guy? Here he is, the 25th. It was just this little lobe here, but every day another little line shows up. And now we're seeing a bump out here. If you compare that to here and here, we're getting the sense that maybe another giant pocket like this event is going to start showing up somewhere down in here in the next couple of weeks. And we're expecting that, given the magnitude of the westerly winds that occurred and the westerly wind bursts that occurred in October and even prior to that. We would expect maybe not quite that big, but something in that category. Certainly much bigger than anything else other than this one that's occurred this year. If that happens, this is going to really push us way over the top into beyond strong El Nino category. So things Hints of things very positive, if you're into strong El Niños, are starting to show on the charts. All right, let's get to the surface. Let's do the quick review. Westerly winds in this region, actually over here. Westerly winds take warm water that's normally piled up here, push it to the east, creates a Kelvin wave. The Kelvin wave is formed at depth, down 300 meters. It goes the whole way across the Pacific Ocean, hits the Galapagos and Ecuador, pushes itself up to the surface, or gets pushed up to the surface, creates a warm pool, a warm oil slick type pool here on the surface, that gets caught by trades and starts pushing its way off this way. Clearly we notice an obvious El Nino signal. Lots of warm water. The hallmark of El Nino is warm water between 170 west and 120. Draw a box right there. That's called the Nino 3.4 region. If you have warm temperatures in there, like half a degree above normal, they call it El Nino. We're looking at way beyond half a degree above above normal, and covering a much larger area. The 97 El Nino was much stronger back in here, but you know what? This is, because it's a little bit westward displaced, it's actually pushing more warm water into the Nino 3.4 range, and we're very anxious to see the monthly temperatures for October for the Nino 3.4 region. Anyway, notice much cooler than normal here. This is exactly what you'd expect. You get high pressure over here. You get low pressure here. You get the jet stream souped up, pushing storms in the U.S. West Coast. Everything's right here. Let's go back a month real quick and just sort of see. We had warm water, but it's back here in the Nino 3.4 range. Look at this. I'm just going to go back and forth. Back. Notice how much warmer it is now versus back then, now, back then, back and forth. Okay, you get the idea. Anyway, things are developing, evolving very well. This is a very solid El Nino. Let's get into the high-res data. So we're going to go segment by segment. We're actually going back in time, July 14th. This is about when peak heating occurred in the Nino 1.2 region. That is the area between Ecuador and the Galapagos. We were going, oh, this looks like a classic El Nino, sort of like the 97 El Nino, all right up against the coast. But here's where we are now. Yes, there's warming. Yes, it's solid, but nowhere near where it was back in July. You know what? We don't really care. It doesn't mean anything. It's Nino 3.4 temperatures way off to the west that matter. But this sort of sets the stage. There's good warming. These are all 2.25. There's a pocket of 4-degree anomalies here, and we're going somewhere with this in a little bit, but just sort of keep this in mind. So we push off. Here's Mexico here. We're off to the west. We're actually going back to October 20th. We see this, at that time, what we thought was a very good, very solid indeed, 2.25 degree anomalies, and the Nino 3.4 area starts right here and goes off. We go, that's very impressive. Now look at today's image. Much, even more impressive, warmer anomalies, pockets building here again. Watch this. This is what we thought was good. Look at what's happening just recently. I mean, just a major explosion of warm water, much more surface area. All this attributable to Kelvin wave number 3 erupting, and we're going to get into the details here in a second. Let's go off to the west just one more block. And we're seeing the same trend here out to the date line. Here it is, October 20th. You go, very solid. I mean, these are 2.5 degree anomalies, or 2.25 degree anomalies. The Nino 3.4 area chops off here, and it goes 5 south and 5 north. You go, man, that's really solid. And then here we are today, building even more, pushing further to the west. Little hints of pixels in here in the 4-degree range, certainly in the 3.5 degree possible. Just very solid. Now here we go. Here's the trend. That is just for the past 7 days. You see a little bit of cooling here in Nino 1.2 between Ecuador and Galapagos. Who cares? We wrote that off. But we see here, look at this, a broad swath of warming from 120 to 140, and another pockets out to the date line. This is, and we're talking, what is that, half a degree or even maybe more. Very impressive indeed. Let's keep digging in. And finally, here's the root of what is going on. This is the high-res overview. You know, we saw the low-res. The high-res tells the story. Look at this. Pockets, these are 4-degree anomalies. 1, 2, 3, 4, 5, 6, all strung out. None of those were here. We had all this reds, but like, 10 days ago, none of that was here. So here we go, October 23rd. You can see, Yeah, there's maybe hints of little pockets of something there. Not a whole lot going on, though, in terms of the 4-degree heating. Just very solid 3-degree. The whole signature was very solid, but nothing outrageous. Now, we're going to go back even further. September 19th, this is what we said was the peak of Kelvin wave number 3 eruption. Notice this, 5-degree anomalies here. Big pocket of 4-degree anomaly. Westward displaced, the Galapagos are right there. The eruption was not here. It was west of there in 100, it's pretty much, south of Mexico. And we go, that was very solid. Then we got to, and it erupted and kind of went in spurts, and we were actually expecting this or more than this to occur. And then come about the 23rd, it just kind of went to sleep. We go, God, after all that westerly anomalies, all the hype around the massive Kelvin wave that was supposed to be forming, we saw all the data, we would just expect more heating to occur than would have occurred. And then just starting about October 27th, all of a sudden, boom, 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 this guy starts waking up. We see not 5-degree anomalies, but 4-degree anomalies strung all over the place. We go, aha, looks like a second pulse of Kelvin wave number 3 is starting to show. So we did a little analysis this morning, or just a little zoom in. So here's zooming in. Here is peak on 9/19. Look at this. We considered this the peak of Kelvin wave number 3. Here's the Nino 3.4 region right out here. So the thought is all this warm water gets caught by the trades, eventually starts working its way over here, which in fact it has done. And that's what's created all that warming that we saw way out into here, doing its thing. But it just wasn't as jaw-droppingly awesome or as impressive as one would have expected given the magnitude of the westerly winds that created the Kelvin wave. And then as we talked about, somewhere after the 19th, all this disappeared completely, and it was just, the reds, not the deep reds. Then, second peak of Kelvin wave number 3, we're calling it October 29th. Look at this. 1, 2, 3, 4, 5, 6, 7, and not only is it all happening east of the of Nino 3.4 region, but actually in it itself, in it proper, majorly impressive. Okay, now here is the index here. Here is the 2.5 degree anomaly line, which if you get temperatures up in there, you're cooking warm as far as anomalies go. This is OISST V2, which tends to read a little bit hot, and we're very interested in seeing what the October numbers coming out of the ERSST V4 reading for this area in October. We'll see that probably in the November 4th, 5th time frame, something like that. But the point being, already we're extremely warm no matter what index you look at, and with this just developing and all this warm water working its way off into here, the numbers are only going to go higher. Again, very impressive. We're going to post this chart on the site at some point, maybe Tuesday, on the Tuesday night update. But anyway, this is a major development. It's happened very rapidly and is very significant because the more warm water you get in here, the more juice you start feeding up into the jet stream, the stronger the jet stream starts raging, the more it supports storm development in the Gulf of Alaska and western Gulf of Alaska in winter months. And we suspect that when the inactive phase of the MJO, no matter how weak it might be, starts fading, and if in fact that little push by the active phase happens in December, things are going to get extremely interesting. And really the issue is are these water temperatures in here going to exceed the 97 El Nino? If that happens, hold on to your hats, folks. And we don't want to be an alarmist. We're certainly not going there. But in terms of records, things are looking very good to say we are at least going to come very close to what happened in 97 in terms of heating in the Nino 3.4 region. All right. Warm water in Nino 3.4, great thing. Doesn't mean anything, though, if it's not having an effect on the atmosphere. Let's go take a look. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. If you have high pressure over Darwin and low pressure over Tahiti, you start getting negative numbers. And you can just see it right here. Look at how deep this went here back early in October. This is when that major Kelvin wave, or westerly wind burst number 4 was going on, 42 minus 49. And now with the inactive phase of the MJO. Still, we have negative numbers, minus 30 for daily numbers, but also some weaknesses are starting to show up of late too. Not bad, still negative. 30-day running average, this sort of gets all the bumps out of the road and sort of gives you a rough idea of what's going on. If you're at minus 20 or so, you're in El Nino territory. We were at minus 22.65 there. Things are starting mellowing out. Again, a little hint of evidence that maybe the inactive phase is taking its toll. Nothing significant. And then the 90-day running average, if you're at minus 18, you're in very solid territory. Clearly, we are there and have been there for some time. So the Southern Oscillation Index clearly indicates some sort of El Nino pattern in play. Here's the 30-day running average on a chart. From 2013, 2014 is when this El Nino actually started. Major shift in the pattern here in the Southern Oscillation Index, but it didn't hold. But then slowly, you can just draw a line through this. The trend has been down and down and down. Here we are right now, hanging, around minus 19, minus 18, something like that. We expect, and you can actually see pulses of the MJO or some variation, inactive phase, active phase, inactive, active. So we've been through a little bit of an active phase. Now we're going a little bit inactive, but it would not be surprising to see this guy go even deeper as we get towards December. The ESPI, instead of measuring differences in pressure between Darwin, Australia, and Tahiti, where it's roughly somewhere right around in here, this is differences in cloud cover, satellite-defined cloud cover. Notice these are anomalies, differences in normal. The browns say drier, less clouds than normal. Wetter here than normal. Typical to see more cloud cover over top of that very warm pool that's right here. And then you can create an index, which has been done. Current value, positive numbers suggest more clouds over here, suggest an El Nino pattern. 1.81, down a little bit. It was up in the 2 range and had gotten as high as 2.4, but still very clearly historically in El Nino, strong El Nino territory. And there are other indexes coming out. We're very interested in the sea surface temperature numbers for October. They only come monthly for the Nino 3.4 region. That they should be coming, let's say, the first week of November. We want to see what that's all about. There's also the multivariable ENSO index that takes, cloud cover, Southern Oscillation Index, water temperatures, a bunch of things, and all mashes it together. It's been tracking dead midway between the 82 El Nino and the 83 and the 97 El Nino, and we want to see where that goes. We expect it to continue on that trend. Most of this ENSO stuff peaks out in the November to January time frame, so we're getting close to where we want to see some significant signs, at least of all the indicators. The actual signs of El Nino, that is rain, weather, wind, all that kind of stuff, doesn't really get going until January, February, March time frame. And because this El Nino is a late bloomer, it's been maddeningly slow getting its act together, but it's been consistent. It's taken a year and a half to get there, but it's there. And all the indexes suggest the atmosphere is aligned, but we want to see it in the jet stream. We want to see storms, and so far, we've had some surf, we've had some storms, but nothing too out of the ordinary so far. But we think it is just a matter of time. And so since we're talking about sea surface temperatures in the Nino 3.4 region, models from the CFS V2, this is the PDF corrected. Truly a joke. It already says water temperatures have peaked out. We don't believe that. It's peaked out supposedly October 1st. We're writing this off. But the uncorrected data, the raw data from the model, is far more realistic, suggesting peak water temperatures at about 2.6 degrees, which would be very warm indeed. That would put you right in, for a one-day reading. A monthly average, probably in the 2.5 range, if that were to really happen, per ER, SST, V4 numbers. If you were in 2.5, that would blow away the 97 El Nino. But either way, it suggests we're somewhere in that territory. We've been writing this off, saying, God, that, like a month ago, saying that those numbers are way too high. We're expecting 2.2 or 2.3, but with what we've just seen on the charts, maybe this is not at all unreasonable. So anyway, peak water temperatures per this November, December time frame. By January, things start collapsing temperature-wise, but just getting going atmospherically. There's a lag. The warm water drives the atmosphere. It takes a while to turn the atmosphere. It's a very big boat, but once it gets turned, it doesn't stop, and it will just blast through winter and spring. Anyway, so that's that. So the short of it, storm forecast for the northern Dateline region for Wednesday or so. Probably a decent, small, north, shadowed, long period swell, San Francisco area, a little bit bigger everywhere else. Also, small, well, not small, medium-sized, very north-angled swell currently working its way into California. Also, a little bit of southern hemi swell still working its way to the north. The big story, of course, El Nino, major warm-up in a major eruption of Kelvin wave number 3, part 2, occurring right now. Warm water working its way into the Nino 3.4 region. All the indexes will be updating in about a week. We're very anxious to get our mitts into those and see where they go. So that's it. Things are on track, looking very good. We'll do this again next week. Same time, same channel. See you then. Thanks for watching.